Change, 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 change.
I'm going to take the derivative of this function using the chain rule. So whenever I do the chain rule, I think of it as taking the derivative of the outside and multiplying it by the derivative of the inside. Actually, I'm going to rewrite this, if you don't mind, Ms. Stewart.
I don't mind.
I'm going to rewrite this as 2x to the fifth minus 7x to the 1/2 power. That's really what a square root is. And the chain rule says, in order to find the derivative, we take the derivative of the outside. So I'm just going to ignore this just for the moment and think of it as just some stuff to the 1/2. Then I'll use the power rule, bring the 1/2 down. 1/2, some stuff, I'm just copying that stuff exactly as it is, subtracting 1 from the exponent, negative 1/2. And I'm going to multiply it by the derivative of the inside. And again, I'm just using the power rule, 5 times 2, 10, x to the 4th, minus 7. And that's basically it. Now I can just simplify this a little bit. I don't like to leave things as negative exponents. So I'm just going to simplify this. I'll move this downstairs. Did I say downstairs? The denominator. Do you say downstairs, Ms. Stewart?
I do.
Bring it on downstairs. So negative exponent, I'll write this downstairs as 2x to the fifth minus 7x to the positive 1/2. This 1/2, this 2 is really downstairs as well. I'll write that 2 downstairs. And the only thing I have upstairs, you say upstairs as well?
I do,
I'll put this
strangely enough.
upstairs. And that's it. I'm done. That is the derivative.
Let's take the derivative of this function. So, f of x, here we have an inside and an outside. Perfect situation to do the chain rule. So as Mr. Haas said, chain rule is just take the derivative of the outside, multiply it by the derivative of the inside. Here we go. Derivative of the outside, I do exactly what you do, Mr. Haas. I cover that thing up and just think, oh, it's something to the 4th. Something to the 4th. I know how to do that. It's
Yeah, no
the
problem.
power rule.
Sure.
Bring that 4 down. It's that something raised to the 3rd. All right, let's just fill in that something, x plus 9 over 4x squared minus 1, times the derivative of the inside. Okay, now I have to look at that and think, that inside is a quotient, by golly. So I have to use the quotient rule on that. So let's use the quotient rule. Mr. Haas, since you're such a nice guy, I'm going to do your order. So the derivative of the top times the bottom as it is, minus the top as it is, I have to think of your order, times the derivative of the bottom, which is 8x. Am I doing this right so far?
That looks great. Now I know you do for the second one. You do the derivative of the bottom times top. Same exact thing.
Yeah,
of course,
just
right?
different order.
Doesn't matter.
Or, of course, you can do low d high minus high d low, square the bottom, and away we go. All right, here we have the derivative. Now, if I just say take the derivative, you're done. I've taken the derivative. But if we say take the derivative and simplify, then you have to go further. And it's a little confusing about how to simplify. Usually when we say simplify something like this, we say smoosh everything together into one happy fraction. All right? So I'm just going to draw that fraction line, figure out what's upstairs, what's downstairs. 4.
I'm going upstairs on that
I am
one.
too, upstairs.
All right.
Okay, x plus 9 is upstairs, and don't forget it's raised to the 3rd. So x plus 9 raised to the 3rd. 4x squared minus 1 is clearly downstairs, and it's raised to the 3rd. So don't forget that part. So far, so good? I'm downstairs. Let's stay downstairs. Here's the next downstairs item. Sneak that right in. And then upstairs is this whole shebang, right? That's all gathered in one set of parentheses. So I'm going to keep that one set of parentheses. Mr. House, do you mind if I distribute and clean that up a little bit? 1 times 4x squared is 4x squared. 1 times -1 is -1. Let's see. That's kind of like a -8x. So -8x times x is -8x squared. -8x times 9 is -72x. And there I have everything on the top and on the bottom. So it's all one big fraction. Now I just see if I can clean things up a little bit. Look how cool this is. Can I clean that up a little bit? Yes, I can. How many 4x squared minus 1s do I have? 1, 2, 3, 4, 5. And you can always leave it like this. We certainly aren't going to ask you to multiply that out or expand that out. Let's see, the numerator, again, in this context, we never expect you to multiply these things out. You can leave them in factored form. We just expect you to kind of clean up each one of the little factors. So let's see if we can clean this up, combine like terms. 4x squared minus 8x squared looks like a -4x squared. Minus 72x, getting a little cramped, minus 1. Now, the one next thing you might want to look at is there anything I can factor further? For example, maybe that trinomial might be factorable, that then would allow me to divide, but that's not looking factorable. So my derivative is simplified. And I'm just going to say it again. Usually when we say simplify, that means we multiply everything together and expand everything. Not so in this context. You leave things as a nice, happy fraction, and leaving things in kind of their factored form is considered fine.